So coming to TTL NAND gate, this is the circuit diagram for TTL NAND. We have 4 resistors R1, R2, R3 and R4, where R1, R2, R3 are parallelly connected and R2 and R4 are serially connected. We also have transistors, 4 transistors, Q1, Q2, Q3 and Q4, the orange circle. These are transistors. Okay, so this circuit is built using 4 resistors and 4 transistors. Q1, Q2 are parallelly connected. This is not serial connection, it is parallel connection. Q3 and Q4 are serially connected, and with Q2, Q3 and Q4 are parallelly connected. Okay, so this hope it is understandable. This is the circuit diagram for TTL NAND. Now coming to Q1, when you see this transistor, unlike the other transistors, it has 2 emitters. Okay, are you able to see? 2 emitters are here. So this transistor, it is called as 2 emitter transistor. All right. So for this whole circuit, we have inputs going from here. A and B are the inputs and Y is the output. Okay, A and B are the input, Y is the output. So apart from all these devices, we have a diode here. Okay, so what is the function of this diode? Diode helps in speeding up the process. Okay, Q1, when we take a closer look at Q1, it looks like this. We have Q1 here. This is connected to Q2, like we have seen in the circuit diagram. Q1 is connected to Q2. Okay. Here I have the inputs A and B. So in this circuit, in this transistor, we have 3 diodes, D1, D2 and D3. When we see these diodes, D1 and D2, it is in reverse direction. If it is in reverse direction, the process it does is reverse bias. Okay, reverse direction means reverse bias. Forward direction means forward bias. Now what happens? What is the difference between reverse bias and forward bias? If I'm going to send 0, low value from A, if I'm going to send low value, then the switch will be open. So here also diode is considered as a switch. If I'm going to send 0, if I'm going for reverse bias, if I'm going to send 0, the switch will be on. For reverse bias, if I'm going to send 1, my switch will be off. Okay, so on means what will happen? The current that is passing from here, it will flow towards A. Okay, so if I have 0, this diode will be on and the current will flow through here and go to A. Similarly, if I have 1, this will be closed, so my current can't flow through here and reach A. Similarly, in forward bias, what happens? In forward bias, if I have 1, then it is on. If I have 0, then it is off. Okay, high value means on, low value is off. So now if my A and B are 0, what will happen? My D1 and D2 will be in on condition. On condition means my current will flow through A and it will go to B. Okay, so I won't have any current left to go through D3. Able to understand? All my current will go through D1 and D2 and I won't have any current to pass through D3. So what happens? My Q2 won't be triggered. I won't have any process happening in my Q2. Similarly, if I have 0 here and 1 here, what will happen? Now the switch will be on. Here it will be off. On means part of the current can flow through here. Part of the current, when it reaches here, there is no flow. So what will happen? Only little of the current will move here, which won't be sufficient to trigger Q2. So again, when I have 0 here and 1 here, what will happen? I won't have sufficient current to trigger Q2. If I have 1 here and 0 here, again it is the same. I won't have sufficient current to trigger Q2 or short circuit Q2. When I have 1 and 1 here, both will be in off state. Both D1 and D2 will be in off state. My current can directly flow through D3 and trigger Q2, which will help in short circuiting Q2, and then the current can flow to the other parts of the circuit. Okay. So here, when A is 0 and B is 0, what happens to D1 and D2? Both will be in on state. And this is the base. So through the base, the input comes. So we will have input going here, going out. Okay. So we won't have any current flowing through Q2. So Q2 will remain off. So this is base, this is emitter, this side is emitter, and this side is collector. Again, when A is 0 and B is 1, what will we have? D1 will be on and D2 will be off. What will be Q2? Q2 will be off. Similarly, for 1, when A is 1 and B is 0, my D1 will be off, D2 will be on, and Q2 will be off. When my inputs are 1 and 1, 1 and 1, my D1 will be off, D2 will be off. At that time, all the current can flow through D3 and it can trigger D2, short circuit D2. So when any of my input is 0, Q2 is off. When both are 1, my Q2 is on. So now, as we have understood the working of Q1 and how the Q2 is getting switched on and off, we will see the working of this main circuit. So when A is 0 and B is 0, Q2 is off. Okay, so when Q2 is off, what will happen? My voltage, the 5 voltage, it will flow through here, come this way, and it will go to Q3. Since this base is the input, current can flow only through here. So when voltage comes here, Q3 will be short circuited. That means it will be open. So my current, it can flow through this diode and reach Y. It does not go down. Why? Because since Q2 is closed, there is no passing of current here. So we have Q4 also in off state. Q2 is off means Q4 also will be off. So when I have A and B as 0, Q3 will be triggered, it will be short circuited, and I will have 5 volt going to Y, which gives me the output as high. Similarly, for 0 and when A is equal to 0 and B is equal to 1 and A is equal to 1, B is equal to 0, the same process happens. Now, when A is equal to 1 and B is equal to 1, what happens? My Q2 is on. Okay, Q2 is on and I will have current voltage flowing from here. Since this Q2 is on, it is short circuited and it will allow current to flow. So since current flows through here, what will happen? Q4 also will be on. Q4 will be on. Now the current that is passing through here, the voltage that comes through here, that will again make Q3 on. So now since Q3 is short circuited and Q4 is short circuited, what will happen? The current flowing through here, it will come down and it will be quickly pulled down by this ground. So I won't have voltage flowing to Y. So what will be my output when my A and B is 1? My output will be low, and that is how I got 0 here. So this is how TTL NAND works.